Hello students, welcome to my YouTube channel. In this video lecture, we are going to answer questions from point of safe written point of equal time chapter in Keith Williams' Gen Math book. Let's begin with question 101. Distance A to B 2500 miles, ground speed outbound 370, homebound 480, endurance 6 hours 30 minutes. What is the time from A to the point of safe return? Okay, so first let's find distance to the point of safe return. Endurance into outbound into homebound divided by outbound plus homebound. So what is endurance here? It is 6.5. Outbound speed 370. Homebound speed 480 divided by 370 plus 480. So 370 plus 480 is 850. In the numerator we have 6.5 into 370 into 480 1154400. So distance to point of safe return will be 1358. Time to point of safe return will be distance to point of safe return divided by outbound speed. So 1358 divided by 370. That is 3 hours 40 minutes or 220 minutes or 220 minutes. So option alpha is the right answer. What is the time to the point of safe endurance if aircraft has a task of 300, endurance of 40 hours, wind component on the outbound leg is 50 knots, headwind. So this is point A, B. So point of safe return is here. On the outbound leg you have a headwind component of 50 knots. On the homebound leg that same wind component will become a tailwind of 50 knots. This is your aircraft at point A. Aircraft at point of safe return. Task is 300. Over here the task is 300. Now, what will be the outbound ground speed? It will be true airspeed minus headwind. So 300 minus 50, 250. Homebound ground speed 300 plus 50, 350. So next step, distance to the point of safe return equals to endurance into outbound into homebound divided by outbound plus homebound. What is endurance here? It's 40 hours. So 40 into 250 into 350 divide by 250 plus 350. So 250 plus 350 is 600. In the numerator we have 40 into 250 into 350, 350, 1, 2, 3, 4. So that is equal to 5833 nautical miles, 5833 nautical miles. Now, time will be distance divided by outbound speed. So 5833 divided by outbound speed of 250 knots, ground speed of 250. This will give you a value of 23 hours 20 minutes. Okay, so 23 hours 20 minutes. Now here the option there is not one option that has this value. Okay, I think the endurance here should be 4 hours, not 40 hours. It's a printing error. So let's try out that. Erase this. What we'll do is we will write this again. I'll write it here. Distance to point of safe return equals to endurance into outbound. So 4 into 250 into 350 divided by 250 plus 350. So 600 or numerator mein you will get 4 into 250 into 350 350 triple zero. So that is 583 nautical miles. Okay, 583. And time will be equal to 583 divided by 250. So that will be 2 hours 20 minutes or 2.3. So option bravo. So 40 hours is the wrong. It's a wrong value. It's a printing error. Next. What is the time from A to the point of safe return? So distance to the point of safe return is endurance into outbound into homebound divided by outbound plus homebound. So 8 hours 30 minutes, 8.5 into 420 into 400 divided by 420 plus 400. So 820, 8.5 into 420 into 400 is 1428,000. So distance is 1741 nautical miles. Time will be 1741 divided by 420, 4 hours 8 minutes into 60, 249 minutes. Option bravo. Next. What is the distance to the point of safe return? So distance to the point of safe return equals to endurance into outbound into homebound divided by outbound plus homebound. So it's 9.5 into 550 into 400 divided by 550 plus 400. 950 in the denominator. 9.5 into 550 into 400. Is equal to 2200 nautical miles. So option alpha. Next, 105. What is the time to the point of safe return? So distance to the point of safe return is endurance into outbound into homebound divided by outbound plus homebound. 8.5 into 400 into 380 divided by 400 plus 380. So distance will be 780. In the denominator, 8.5 into 400 into 380. 1292 triple zero. Divide by 780, 1656 nautical miles. So time will be 1656 divided by outbound speed 400, 4 hours 8 minutes or 280, 248 minutes. Okay. So 249 is the closest option. So option Charlie. 106. What is the time to the point of safe endurance if TAS is 300, endurance 5 hours, wind on the outbound leg 30 knots headwind? So here is your point A, here is your point B. Here is your point of safe return, aircraft. So here is, okay. Now the TAS of this aircraft is 300. So TAS 300, TAS 300. And you are getting a headwind of 30 knots on the outbound leg. So 30. And that will become a tailwind on the homebound leg. So minus 30 plus 30. Now, what will be the ground speed outbound? 300 minus 30, 270. What will be the ground speed on the homebound leg? 330. Okay. So distance to point of safe return is endurance into outbound into homebound divided by outbound plus homebound. So endurance equals to 5 hours. So 270 plus 330 is 600. Numerator 5 into 270 into 330, 445,500. Is 742.5, that is 743 nautical mile, let's say. So time will be distance to PSR into outbound speed. So 743 divided by 270. 2 hours 45 minutes into 60, 165 minutes. So option, so 2.75 delta. Okay, next. What is the time to the point of safe return? So distance to the point of safe return is endurance into outbound into homebound divided by outbound plus homebound. So endurance is 3.5, outbound speed is 420, 480 divided by 420 plus 480. 420 plus 480 is 900. 3.5 into 420 into 480 is 705,600. That is equal to 784 nautical miles. So time to PSR will be distance to PSR divided by outbound speed. So 784 divided by 420, which is equal to 1 hour 52 minutes into 60, that is 112 minutes. So option A. What is the distance to the point of safe endurance if aircraft has a task of 300 endurance 10 hours? Winds on the outbound leg is 30 knots headwind. So this is your point A, this is your point B, this is your point of safe return. Here is your aircraft. You're getting a headwind of 30 knots on the outbound leg. So this is minus 30. That same wind will become a tailwind of plus 30 on the return leg. Task is 300. Task is 300. So outbound speed will be 300 minus 30 to 70. Homebound speed will be 300 plus 30, that is 330. So distance to point of safe return is endurance into outbound into homebound divided by outbound plus homebound. What is endurance? 10 hours. So 10 into 270 into 330 divided by 270 plus 330. Is 270 plus 330. It is 600. In the numerator we have 10 into 270 into 330, that is 891,000, which is equal to 1485 nautical miles. So option alpha is the right answer. 109. What is the time to the point of safe return? So first let's find distance to the point of safe return. Endurance into outbound into homebound divided by outbound plus homebound. Endurance is 3.5, outbound speed 220, homebound speed 280, 220 plus 280. 500. In the numerator, 3.5 into 220 into 280, 215600. That is equal to 431 nautical miles. So time will be 431 divided by 220. That is 1 hour 57 minutes or 118 minutes. So option delta. Last question. What is the time to the point of safe endurance if aircraft has a task of 200 knots, endurance of 10 hours, wind on the outbound leg is 45 knots headwind? So point A, point B, point of safe return. Outbound leg we have 45 knots headwind. On the inbound leg it will be a 45 knots tailwind. Okay. Here is your aircraft A. Here is your aircraft at point of safe return. Now task is 200. Outbound ground speed will be 200 minus 45, that is 155. Homebound ground speed will be 200 plus 45, that is 245. So distance to point of safe return is endurance into outbound into homebound divided by outbound plus homebound. So 10 into 155 into 245 divided by 155 plus 245 is equal to 400. Numerator 10 into 155 into 245, 379,750. That is equal to 949 nautical miles. Okay. So distance to point of safe return is 949 nautical miles. So time to point of safe return will be distance to the point of safe return divided by outbound speed. So 949 divided by 155. 6 hours 7 minutes or 6.1. Okay. So the correct answer here is option alpha. Simple. So this concludes our lecture. I hope you have understood all the 10 questions I have answered. If you have any questions, let me know. Thank you for your time. In the next video lecture, I will solve the next 10 questions. So let's see you there.